Okay, great. So the session's now recorded. So as I said, my name is Doug Oldfield. I'm going to be taking today's session, which, as you can hopefully see from the screen, is an introduction to risk analysis using at-risk with a cost estimation and risk register focus. So the first thing I need to do, whilst I remember, is to share out my desktop so you can all see what's going on. So let's just wait for that to share out. So hopefully you can all see the Palisade homepage loaded up on your screens via the WebEx. So what I'll do, just before I start looking at the software, I'll give a very quick overview of a couple of things on the website which are really valuable resources going forward. Obviously, the point of today's session is to give you an introduction into how you go about building up a model using at-risk in a cost estimate or risk register context. And so hopefully by the end of today's session, if you're not already a user of at-risk, you'll have a good basic understanding of how to go about using the software and which functions you can use. But then going forward, obviously we do lots of training courses, etc., which are always incidentally to be found under the training schedule here. But there's also lots of free resources on our website which are really designed to help you get started understanding the software, etc. And so I'll just point a couple of them out just so you're aware of them, and then you can always look at them after the session. So first of all, under training and events, we have all of these videos set here. So they're different categories. Excuse me, which range from some example models which are then kind of built up on a step-by-step basis, through to some various experts talking about the different features of the software, and step-by-step tutorial videos which go from everything from how you'd go about setting up a distribution to running a simulation and so on. Some of the key functions and features all kind of explained. If you want to find out a little bit more about how some of our other customers are using the software, then we have a number of different case studies here from different industries, lots of different companies talking about how they apply at-risk and the other tools in the decision tools suite. And on here we've also got some industry models and some customer lists as well. So what we're going to be looking at today, we're going to be looking at risk. Now, Palisade, we actually supply a complete set of products in this risk and decision analysis toolkit, which we call the Decision Tools Suite. And although today is just going to be looking at risk, just be aware there's also a few other tools which are available, which run from a decision tree software called Precision Tree. There's a tool for sensitivity analysis called TopRank, tools for optimization, and a couple of statistical analysis packages as well. From a cost estimation perspective, which is what today's session is really going to be focusing on, I'd say that probably the two most valuable ones to be looking at are at-risk and TopRank. If we've got time at the end of the session, maybe I'll give a quick overview of TopRank, but I'm mainly going to be concentrating on at-risk today. So let's load up the software so we can get started. So at-risk, what is it? Well, it's essentially a tool which is an add-in to Microsoft Excel. And when we say it's an add-in to Microsoft Excel, what I just did, I just clicked on the icon to load the software up. And you can hopefully see on my screen that what's happened is that actually Microsoft Excel has loaded up. And so here we've just got a blank Microsoft Excel workbook. And up here in the toolbar, we have this new toolbar for the at-risk functionality. So at-risk has essentially added some functions into Microsoft Excel that weren't there before. And these functions allow us to run some different types of analysis, to run something we call probabilistic or quantitative risk analysis or uncertainty analysis or Monte Carlo simulation. All these terms are relatively interchangeable. But essentially, what the software is, it's a bolt-in to Excel which allows you to convert any Excel model which has any kind of predictions or forecasting into a much more robust and quantitative model than Excel on its own. And so I'll explain what I mean. I'll just if I just load up my first example spreadsheet, which I'm going to be looking at. This is this is an example of a cost estimate model. So this is I suppose, set up as a deterministic model, and this is how a lot of companies, including I'm sure many people who are on the call today, use Excel, and this is what we would call a deterministic or a static model. I'll just kind of explain the model because we're going to be looking at this in quite a bit more detail over the next hour or so for the duration of this session. So this is just a little cost estimate model where we've got a number of different cost elements here, and 8 of them in total, each of which are contributing to the cost of our overall project. So the first point is that each of them have then been given a base case cost. So this is where the project manager or the project controller or planner or whoever it is has just really kind of given a best guess as to how much each of these cost elements is going to cost, ranging from 500 for vehicles up to 5,000 for buildings. And so this is our first kind of estimate for this particular project cost, and so actually it's 18.5 million is the first estimate for the cost of this particular project. Now, this is actually how quite a lot of companies use Excel, just by assigning single point numbers into variables, adding them up, and then really looking at the total, and then really using that to then make some business decisions. Sometimes companies then maybe expand out on this by accepting that there is some level of variation into the costs which are likely for a particular project. And so here we've actually got a 3-point estimate which has been built in. And so for each of our 8 costs, we've now got a minimum value, a most likely, which is exactly the same as the base case cost here, and then a maximum value. So this has now given us some level of variation in our costs, where actually we have this whole range of different values or possibilities. And so instead of costing 18.5 million, now we're saying that our project is going to cost anywhere between 14.6 and 26.5 million, say. So now all of a sudden we've got a number of different values rather than a single value, but there's still some problems which are endemic in this particular type of approach. So, well, first of all, I suppose there's no real way of telling from this particular model here whether it's more likely that we're going to be at the low end of things and our costs are going to be 14.6, or whether actually they're going to be up here. And of course, there's a $10 million difference in the cost of these 2 particular projects, which is probably going to be unacceptable for many companies. The second issue is this doesn't really give us any idea as to which are the key drivers in our particular model. It doesn't allow us to build in any dependencies. You know, if the cost of our salaries increases, is the cost of our IT also likely to increase? We can't really build that in very easily using Excel. And of course, this doesn't really give us much in the way of actionable information. And so the idea of at risk is really to take this model, to take this this kind of deterministic model and turn it into a probabilistic model. And what I'm going to do over the course of this demonstration, I'm going to effectively build up the model you just saw into a kind of a probabilistic model like this. I'm going to run a simulation, and at the end of it, what we're going to get to see is, instead of just seeing 1 scenario or 3 scenarios for our particular project, instead we're going to see 1,000 or 10,000 or 1,000,000 scenarios for our particular project and how likely they are to occur. And so now, rather than talking in terms of you know, the cost of this project is going to be 18.5 million, we can see that actually there's something like a 20% chance that the cost of this particular project is going to be equal to or less than 18.5 million, and there's huge kind of 80.4% chance that it's going to be higher than that. And so that's kind of what at risk is going to do. And I think sometimes it's quite helpful just to show you what's going to happen at the end of the demonstration, so that you're kind of aware of what's going on as I'm building it up and talking about it. So it's really about taking a deterministic or static model, adding in these things called Monte Carlo probability distributions, running a simulation, and then looking at the results. And then at the end of it, we can then start to make such statements as okay, so there's a 95% probability that our costs for this particular project are going to be less than 25 million, or there's a 10% chance that our initial budget isn't going to be sufficient for this particular project, and so on. So that's what we're going to see at the end. So I'm just going to close that down. I'm going to I'm just going to start off with a kind of like an empty version of this model. Now, there we go. So let's reload up our risk, and then I'm just going to load in. Once at risk is loaded, I'm then going to load in the example model as well that I'm going to use. So it's worth saying, just while I'm loading this in, that the reason we're doing this cost estimation and risk register session is really because it's one of the most common and most popular uses of at risk. But there's lots and lots of different uses that the software can be used for, ranging from things like NPV analysis to demand forecasting, sales forecasting, reserves estimation. There's a huge amount of different applications for the software, and really at risk can be applied to any Excel model where we make any kind of forecasts. And we actually there's looking at the attendee list, there's people on this call from oil and gas, from mining, there's people from government, from pharmaceuticals, from engineering, from construction, and we actually sell to pretty much every single industry that you can think of. And the reason why we sell to every industry that we can think of is that because the software adds into Excel, Excel is obviously the business standard for spreadsheet and modeling and reporting, etc. And so we sell to anyone who can use Excel. And so obviously there's a lot of different applications of the software and a huge amount of different industries. Okay, so what I'm going to do, as promised, I'm going to take this deterministic model here, and I'm going to use it to build up a probabilistic or Monte Carlo model, if you like. And we're going to look at the cost side of things here, and then we're going to talk about how you can incorporate a risk register into this. And hopefully, kind of as I go along, you'll see how simple it is really to build up an at-risk model. And the reason it's so simple, of course, is because it's all now in just within Excel. So if you can already use Excel, then the learning curve is actually pretty smooth for the product. It's just a question of learning a few more functions and how to apply them. So the first thing that we need to do with that risk is we need to look at our model, either an existing model or a new model, and we need to look for where there is some uncertainty or variation. And so the idea behind that risk is because life is very much uncertain, at risk is a tool that we can use to try and capture or model that uncertainty, and then to make better business decisions based on it. And so what I'm going to do, I'm going to build in some distributions. So it's all about adding these things we call probability distributions. So I'm just going to click the Define Distributions button. And here we have what we call the distribution palette, where we have all the different types of distribution with lots and lots of different types of distributions, which sometimes scares people. But typically speaking, the most commonly used, probably by 99 or more % of our customers are grouped together here. They're split into things we call continuous or discrete distributions, which I'll explain a little bit more about as we go along. But essentially, the different types of distributions are then used to generate different scenarios. So instead of us being stuck in this deterministic or static world, all of a sudden we can have this very dynamic model where we show lots and lots of different scenarios. And so when I just ran a quick simulation before with the completed version of the model, all I did then was I asked that risk to take 1,000 samples from a number of these probability distributions, and then what you saw, the histogram and the S-curve, were really the cumulative results of that simulation. So we have lots of different types of distributions. There's lots of information about what type of distribution you should use for particular applications on the internet, on our website. There's a full user manual and help guide contained in the software under documentation. And for anybody who is quite new to probabilistic analysis, a very good book to actually read is one called Sam Savage. Oh, the floor. You can see my typing is not as accurate as I'd like it to be. Sam Savage, the Floor of Averages. If you want a good introduction to probability distributions, the shape of distributions, etc., I'd certainly recommend taking a look at this book if you do get the opportunity. So that's Sam Savage, The Floor of Averages. So what it is, so with the software, it's about taking these probability distributions and then using at risk to run some simulations and to generate lots and lots and lots of different scenarios. And so I'm just going to pick in here something called a PERT distribution. So from a cost estimation perspective, just to kind of shortcut things a little bit, two of the most common distributions are Pearson triangular distributions, but we could also use things like a log norm or uniform. I'll go into a little bit of detail as we go along about the types of distribution, but it's really a fairly in-depth topic about how do you select the right type of distribution, etc. But so for now, I'm just going to select a PERT distribution. So this is my distribution for land, and because I want it all to be quite neat and tidy, I'm going to say that I want this particular distribution to be actually called land. So at-risk has got an intelligent naming function which kind of looks for the best match in terms of what the name of a cell should be called, but you can enter it manually if you want to. And so what I'm going to do, I'm going to say that I want, in this particular cell, I want there to be a distribution. And I'm going to use one of the really neat little functions in at-risk, which allows us to use Excel cell references as arguments for distributions. And so I'm going to say that I want there to be a distribution with a minimum value of this, a most likely of this, and then a maximum of this value here. Okay, so what I've just done, so this is I just click this button here, which is great. It's allows you to assign these Excel cell references as arguments, and because the tool is an add-in to Excel, all of the standard Excel functionality is supported. So drag and drop, copy and paste if you want to use min-max functions, lookup tables, however you want to use Excel. At-risk functions in exactly the same way, and so all of the native Excel function arguments, etc., you can incorporate into your risk modeling. So that people can use at-risk on a very basic level, or if you're a very high-powered Excel user, then you can also use at-risk in a similar way. And so what I've just done, I've just built in a distribution for land using these Excel cell references here. So with a minimum of 1.5, most likely of 2, and a maximum of 2.8 million. And that's what you're seeing on this graph here. So here we've got the minimum value of 1.5 million, a most likely of 2 million, and then a maximum value of 2.8 million. And when I click on OK, and then start hitting the F9 button, what you can hopefully see is at-risk is now taking a number of samples from that distribution, and it's now putting them back into my Excel workbook. And so rather than having a fixed value for my land or a 3-point estimate, all of a sudden now I've got this this dynamic value in here, which is changing on a continuous basis from the software, really taking some samples and putting them back into the spreadsheet. And so the way it's working, the software is actually taking some samples which are based on the shape of this distribution. So this is something which sometimes people struggle with at first, because it's a bit of an alien concept. The fact that the shape of this distribution here is somehow being used to generate some numbers, which are then going to be put back into my Excel spreadsheet, which I'm then going to take to management and say this is some random scenario which is going to happen, and this is what we need to do. So I think it's probably worth spending a little bit of time on just explaining exactly what the software is doing here, just so you're aware of it, in case you don't already know. So, as I said, when we have a distribution in a cell, what the software is doing, it's taking some samples and it's putting them back into the Excel sheet, and it's taking the samples based on the shape of this distribution. And so, as things stand, as I said, we've got a minimum of 1.5 million, a maximum of 2.8 million. And so this area, this blue area on the graph, this is equal to 100% of our samples. And so 100% of our scenarios are going to come between 1.5 and 2.8 million. It's never going to be 3 million. It's never going to be 1.4 million. It's always going to be between 1.5 and 2.8 million, because this is what we've put into to at-risk as the parameters for this distribution. And so this is where at least one or two of you will be scratching your heads saying, well, how does the software know where to take the samples from? How does the software know that the cost is 1.5 million or between 1.5 and 2.8 million? And the answer to that is the software, I'll say it a few times during the course of this demonstration, the software functions exactly like Excel does. And so when you build up an Excel model and you build it up as a cost estimator or risk manager or whatever your job function is, it's you who makes the call, and it's you who uses your expertise and understanding and knowledge of your particular field in order to build up an Excel model. And at-risk functions in exactly the same way. It's just rather than thinking in terms of a one-dimensional static model or one-point estimate, instead now you need to start thinking in terms of ranges. And so that's the first thing that at-risk is about. It's really about thinking in ranges. And so in this case, we have this range of values from 1.5 to 2.8 million. And the software is taking some samples then, and it's taking some samples which are based on the shape. And so, as I said, 100% of the samples come from this blue area here. And along the top bit here, these little values up here tell you whereabouts, what the probability is that a sample is going to come from a particular range on the graph. So I've got a few people who are saying they can't hear anything. So I'm just going to okay, so let me just resend the message again. There's a few people who have obviously been sitting there for the last 20 minutes not being able to hear anything. So hopefully the majority of you can still hear. I've got a couple of questions which I'll come back to shortly. But so what the software is doing, it's taking samples based on the shape of this distribution, and 100% of the samples come from here. And so, if, for example, I want to find out what the probability is that my land is going to cost more than 2.2 million, I can see that there's something approaching a 28% chance that the land is going to cost more than that. Thank you very much, Angus. I'm glad you can hear okay up in Scotland. So 28% chance that the land is going to cost more than 2.2 million, and so there's whatever that is, an 82.1% chance that the cost of land is going to be lower than that. And so the software is taking some samples based on the height of this distribution here. And so the higher the curve, the more likely it is that the samples or the scenarios are going to happen from that area. As we get out to these kind of smaller regions down here, these things which we call the tails, there's less surface area, the curve is low, and so the samples are less likely to come from there. Just to kind of explain it in a slightly different way, if you imagine that this here curve has been drawn on the ground in front of you, and you've got a handful of little stones or pebbles or rocks or whatever you want to call them, and you're dropping the stones on top of this distribution. And so instead of using a random number generator and some computational algorithm in the background, which is what at-risk is doing, if you imagine that you're doing this in a real very physical sense, so you've got this curve which has been drawn on the ground in front of you, and you've got a handful of stones. And so what you're now going to do is you're going to drop stones, and the only place they can land is on this curve. Let's say that there's very, very high walls all around here, and so the stones are just always going to drop within this particular curve. And so wherever the stone lands, let's say your first one lands there, you go down, okay, so that's about 2.1 million, and that's your first sample or scenario. You drop another stone, it lands there, your second scenario is 1.9 million. A third stone lands there, that's your third sample, and so on and so on and so on. And you keep doing that over and over and over and over again. And all of a sudden then, instead of seeing just one or three scenarios, you're getting, tens or hundreds of scenarios, depending on how many stones you've got to drop, and then you kind of use them to then build up this idea of all the different possibilities which can happen, and that's exactly what at-risk is doing. And so this particular type of distribution, it's one where there is a bias towards the middle. There's this, we have this most likely, so we've got this peak here, which is the most likely scenario, and then it kind of drops off to the sides. Just to give you an idea as to what a different distribution would look like, if I choose a uniform distribution instead, you can see that actually, whereas a Hurt distribution has got 3 parameters, a uniform's just got 2. It's just got a minimum and a maximum, and that's what's being shown here on this overlay. So instead of having this bias or this peak up here, instead, a uniform distribution is just one which is constant throughout, and so the samples are just as likely to come from here as from here as from here as from here as from here. So there's still uncertainty going on with this particular type of distribution, but actually all we know is that there's a minimum and a maximum, and we don't know, we don't really know if there's any bias in between. So let me just clear that overlay off. So that was a different type of distribution. So just to kind of speed things up a little bit, I have a tendency to explain in too much detail. So do excuse me if I'm taking a bit too long and you already understand how the software works. I promise you I shall start speeding things up a little bit now. What I'm going to do, because it's all Excel based, as I said, we can start to use things like drag and drop, copy and paste. And so what I did, I just went down there and dragged it down. And so now what I have in each of these cells, I've got a distribution which has been built up for each of these cost elements based on this 3-point estimate which has been given here. So now what I'm going to do, I'm just going to add these all up. And then I'm going to set this as something called a risk output. And the reason I'm going to do this is, so what I've got, I just summed up all of these 8 cost elements here. And then for this cell, I set it as something called a risk output. And this is something which is very important to do, because obviously each time I'm hitting F9 and at risk is taking a sample from the distribution, all that's happening here is that we're then just seeing one scenario as to what could happen. And this is kind of no better than the deterministic model, because all we're seeing is one scenario each time we hit F9. And so the risk output, so this add output up here, is really a cell or a value which we want to see what happens over the course of a simulation. Let's just delete that so it's not too distracting. So what I'm going to do, I'm just going to put it in demonstration mode up here. So it's going to run a little bit more slowly than it usually does. And I'm going to click Start Simulation. And what at risk is now going to do, you'll see it in the background here, sort of the Excel sheet changing. What at risk is doing, it's now taking 1,000 scenarios from each of those 8 cost elements, and it's using them to build up this histogram that you see kind of growing here in the background. So hopefully you saw all the cells recalculating here, and now what we're seeing here is we're seeing a graphical representation, if you like, of those 1,000 values. When you start looking at lots and lots of different scenarios, it becomes quite high or quite hard for the human brain to be able to look at a huge amount of numbers and make any sense of them. And so one of the key things about risk is that it then uses those values to build up either a histogram or an S-curve, and to show you those 1,000 scenarios. So what we've got here, this is really the sum total of those 1,000 scenarios. And so along the x-axis, we've got what the range is. So in this case, between 16.4 and 22.3 million. And then the height of the curve kind of really shows how likely it is that a particular value might happen. So if I want to find out, for example, what the probability is that it was 18.5, yep, that my actual total project cost was equal to or less than 18.5 million. I can see that in this case there's something like a 27% chance that my costs are going to be equal to or less than this original base case cost. So pretty poor odds, one in 4 chance that our original project budget is going to be sufficient. If we want to look at what the probability is that our costs are going to exceed 20 million, we can just type these values in up here and find out. Now, of course, as there's a number of costs estimated on here, I'm sure that a lot of people are familiar or conversant with the idea of using percentile values or p-values to describe things. And so, if, for example, we want to find out what our p90 is, so the value for which there's a 90%, we're 90% confident that our total cost is going to be equal to or less than, in this case, our P90 value is 20.46. So there's a 90% probability that our costs are going to be less than this value, and a 10% probability that they're going to be more than this value. So this is kind of what the software is doing. It's allowing you to start thinking in 2 dimensions rather than in 1 dimension. So instead of thinking in this very deterministic single point world, instead what at risk allows you to do is now to be able to go to your manager or to your shareholders, or when you're preparing a bid for a project, instead of having a fixed value in here, all of a sudden you can now go to the project manager or go to the shareholders and say, okay, so there's a 10% probability that our costs for this particular project are going to be more than 21 million. is that acceptable? There's a 90% chance they're going to be less than that. Are we prepared to bid on that? Whereabouts, whereabouts do we have some kind of flexibility in here? What can we do? So it's really about giving you some additional information in order to really help you make some better decisions about what what a particular the best solution is to a particular problem, or how much we should bid for a particular project, and so on. So this is a histogram. There's a few different graph types in here. Some people like histograms, some people absolutely hate histograms. So if you're one of the latter type of person, we also have in here this something we call this is called a cumulative ascending curve, which might be more familiar to a lot of you as something called an S curve. And so this is actually showing exactly the same information, but it's just displayed in a different way. So there's still a 27.4% chance that our costs are going to be less than 18.5 million. But instead of having all of those bars, this is really showing us, so long we've still got the range along the x-axis, but what the y-axis is now showing us, it's showing us the cumulative probability. So the point at which these things we call delimiters bisect the curve. If we then go across to the left, convert this into a percentage, and find out what the value is. So now if we take this value here, we can see that there's a 45% chance that our costs are going to be equal to or less than 19 million, because that's the point at which the delimiter bisects the curve. And if you want to, you can show one on top of the other if you particularly want to see both types of format. And of course, because all this is, at-risk is a very open architecture, there's lots of things that you can do with the software. So if you want to take this and, for the sake of argument, let's say you want to put a couple of markers on the graph to show your P5 and your P90, and instead of having the color red, you want to have the color green. It's very easy to do all these things and to customize the software exactly as you want to. Just bear with me. That color green is going to freak me out, so I'm just going to change it back to red. So this is all very customizable. So if you want to take this information and to pop it into an Excel workbook instead of having it all in at risk, you can do that. So now it's what the software just did was to take that information, populate an Excel graph, and so you can use the Excel graphing engine and so on there. So that's kind of what the software is doing initially. So you identify where there's uncertainty, you run a simulation, and then you look at the results and you interpret the results. But of course, once we've done this, we can then start to look at some of the other functions of at risk. So I'm not going to talk about all of the functions of at risk because some of them aren't really relevant from a cost estimation or risk register perspective. So I'm just going to, over the course of the demonstration, I'm just going to pick out the things which I think are going to be useful and valuable for cost estimation or risk register purposes. And so this is the first thing. So I'm just loaded up, and so I'll just do it again. So I have a tendency to click through quite quickly because I'm quite familiar with the software, but what I shall do it a bit more slowly so people can follow what I'm doing without having to have very, very quick eyes. So what I did, I just clicked on this select type of tornado graph. There's lots of different ones in here. I'm not going to talk about all the differences between them for now, but if we just look at this one here, this is the regression coefficients. What this is showing us, the relationship between our input values and our output. And so it's really showing the strength of the relationship between the variability for each of our cost elements and then the overall project cost. And so what this is showing me, that the thing which is having out of those 8 cost elements, the thing which is having the largest impact on whether my project is delivered to cost or not is the cost of buildings. And so if I just drag this out, so what it's saying is that there's this fairly strong coefficient value or relationship of 0.8. And so if I just drag this out, I'll kind of show you that in a bit more detail. So this is a type of graph we call a scatter plot. And so this scatter plot is actually showing us those 1,000 scenarios. So all of those 1,000 scenarios, which I asked at risk to run when I ran the simulation, are all plotted on this scatter plot here. And so along the x-axis we have the buildings, along the y-axis we've got the total project cost estimate. And so down here we can see that when the cost of buildings is at the low end of things, so our total project cost also tends to be tends to be lower, whereas when the cost of buildings increases, so the cost of the total project tends to increase as well, which is obviously kind of what we expect. When one of your inputs goes up, so the total project cost goes up. But if we look instead at, say, vehicles down here, so we've still got the 1,000 scenarios, but actually you can see that there's a lot less relationship between the cost of vehicles and our project costs. Sometimes the cost of vehicles can be low down here, but the project can still cost a lot. Sometimes the cost of vehicles can be really, really high, but actually the total project cost has never been lower than it is there. So there's not really any kind of relationship. Whereas when we looked at the buildings, of course, you can see this kind of like the shape of this relationship, this positive correlation between the cost of buildings and the total project cost. So once we've kind of run our simulations and looked at this, looked at the values, then obviously there's a number of other things that we can do. So first of all, I'll just kind of talk about one of the kind of quite neat features for me. It's something called the stress analysis. So what the stress analysis allows us to do is, let's delete that and I'll start again. The stress analysis is a way of being able to see what happens in a particular set of scenarios. So it's quite common when you run an at-risk model, and even not using Excel, even not using at-risk, what would happen if our revenues were lower than expected? What would happen if this particular project cost more than expected? What would that do to our overall exposure? How would that impact upon our model? And so when you use Excel, without at risk, really the only way of doing that is, I suppose you could build in some kind of a data table with some lookup functions, or you could go in and you could change things in a very laborious sense, and change each of these values, and then see what happens to the overall cost of the project when you change them. What the stress analysis allows you to do is to essentially take some of the any inputs for your particular model, and then to see what happens in a given set of scenarios. And so what I'm going to do, I just selected a couple of options here. I just selected land and buildings, and I'm just going to see what happens when my land and my buildings are at the high end of things. And so if I click on Analyze and OK, what that risk is now going to do, it's now just run two simulations rather than one. So the first simulation was my baseline scenario where this was the total project cost. Let's take a reference. There we go. So that was my first simulation where my project cost exactly what I expected it to. But if I go to summary, and then whereabouts were we? This one here. This is the stressed model. Now all of a sudden I can see what happens if my land and my buildings are actually in the worst 10% of cases. So if they're very much at the high end of things, what does it do to my overall project cost? And so this is now shown. So this red, the red data on the graph was my baseline model, where there was a 27.5% chance my costs were going to come in at 18.5 million or less. And the blue curve on here, the blue histogram and then the blue cumulative curve, are my stressed model. And so you can hope to see that this is now shifted across to the right. The project is now obviously costing a lot more. The minimum and the maximums have all changed. So for me, it's a very nice, elegant way of being able to communicate very, very quickly and easily without needing to go back in, change your model, rerun a simulation or anything like that, to show what happens if the brown stuff hits the fan and your costs are higher than expected. So that's the stress analysis. Let's just put the baseline back on there. So some of the other things which we can do with the software, as I mentioned earlier on, we can build in some links or these things we call correlations between input variables. So rather than having a number of different cost elements, all of which function independently of each other, obviously in real life that's not necessarily the case. If the cost of one project, if the cost of labour for one project is likely to be high in a portfolio project, so another cost of another project is likely to be high. You have maybe a relationship between the cost of commodities. So there's lots of things in real life which there's a relationship between. And we can actually use at risk to build in these relationships, or we call them correlations, into the model when we build up a risk model. And so I'll just give a little quick example of this. So if I click on define correlations, and then add inputs. What I'm now going to do, I'm just going to select a couple of distributions which I want to be correlated. And so I'm going to say that I want there to be a relationship between the cost of, let's say, my buildings and my raw materials. So if I click on OK, and then this little one option down here to show the scatter plots. Either we can type in the correlation, the coefficient value down here if we've already done that analysis, or if we want to, we can just grab this and slide it backwards and forwards, and we can build in a relationship or correlation between those two values. And so what I'm doing here, when I'm just sort of sliding this backwards and forwards and hypnotizing everybody, you will buy a copy of At Risk, you will buy a copy of At Risk, you will buy a copy of At Risk, or whatever I'm doing, when I'm just using this slider here, I'm actually using At Risk to build in this relationship between buildings and raw materials. And so what this is now showing me, this is now enabling me really to say that so in this case I'm just going to have a positive correlation. Obviously, you have a negative one if you particularly needed to for different application, but I'm going to say that I want there to be a positive correlation between my raw materials and my buildings. And so what this means is when the cost of my raw materials is at the high end of things up here, so the cost of my buildings is also going to be at the high end of things. When my raw materials are sampled at a low level, so my buildings are sampled at a low level. So if I just click on OK, just pop the correlation matrix in there. So this is just a correlation matrix, and now we have a link between these two cells up here. So we've got this risk format matrix, and so when the cost of my buildings is sampled at the high end of things, so the cost of my raw materials is also going to be sampled at the high end of things, and vice versa. So it's about being able to build in these relationships between input variables. And of course, if you've got this is just a little two-way correlation matrix, but you might have a scenario where you have lots and lots and lots and lots of different things all correlated, and of course you can use At Risk to build in those correlations. And there's even some various tests in here to make sure that the matrix is consistent and so on. So it's essentially with At Risk, it's very easy to build in these relationships or correlations between input variables. Okay, well, I suppose the next thing I wanted to show you was really a couple of things about being able to share this data and results, and then we'll look at how you go about applying a risk register to this particular model. So first of all, just as a side, there's a function in At Risk called the At Risk library. This function up here. Now, what the At Risk library is, it's really a little database which can either sit locally on your machine or it can sit on an SQL server. And it's just really somewhere where you can save custom distributions. I'll talk about custom distributions in a little while, results and models. And so it's a really useful thing if there's a number of people in an organisation all kind of building up cost models or MPV models or whatever models that you're using. You can actually build in these custom distributions and pop them into this risk library. And so this is a really neat thing for companies who have got a number of different users. Rather than lots of people all having different values for their distributions, different kind of inputs, etc. Actually, the At Risk library allows you to standardize. And so rather than having 10 analysts, for example, with a different value for oil price, you can all standardize and use the same one. Likewise, you can also put in here all of your results once you've run a simulation, and you can also save models in here as well. So rather than kind of needing to send models around to people, you can, if you're using it within a work group, you could all work off the same at-risk model and save it into the at-risk library. On the kind of subject of sharing, etc., this little button up here for Excel reports is a very useful place to go if you ever need to generate some reports to then share with other people. So we've got a number of different pre-built reports in here, and we've also got the ability to customize our own reports with using these template sheets. But if I just select a couple, quick reports and simulation data. Okay, so at risk is just using the simulation I've run to generate some information. So we've got the histogram, we've got the S-curve, we've got the tornado diagrams down here, the summary information and so on. And I also said that I wanted the data. So here we've got the data for all 1,000 of those scenarios are all just here in an Excel workbook, and so I can take a look at these and run some further analysis on them if I particularly want to. So that's kind of the basic kind of cost side of things. But what I wanted to introduce now and to talk about now is really this idea of risks as well. So this is as things stand. This is this top half was a cost estimate model. So this particular project, there's a number of different costs which we know are going to be facing a particular project, or need to be incorporated into the budget. So we know we're going to budget, and we need to budget for land, we need to budget for builders, we need to budget for raw materials and so on, because these are all an intrinsic part of this particular project. And so this was the cost estimate model up at the top. But the cells that I just unhid, this is an example of what we term a risk register. And so it's possible to combine the two elements into one, which is what I'm going to be doing here. But the idea behind the risk register is instead of having all these costs which we expect to happen, what a risk register allows us to do is also to really capture what would happen if certain things occurred over the course of this particular project. And so I just kind of built up a few little examples down here. So this particular project, there's 4 risks which could happen. Of course, in real life, there's often going to be a lot more risk, but I've just selected 4 here. So we've got an earthquake, bad weather delays, industrial action or worker strike, and then finally a terrorist attack. And so typically, what companies do without Monte Carlo simulation, or when building risk registers in a deterministic sense, is they would, so just to backtrack, a risk register really has 2 dimensions. So first part of a risk register is you really need to capture what the impact is, or severity, if a risk was to occur. And so here we've just got an amount which has been given. So if an earthquake happens, it's going to cost 5 million. Bad weather delays are going to cost 500,000. A work strike could be up to 2 million. A terrorist attack, 3 million. So this is the first part of a risk register. We identify how much it's going to cost if the risk occurs. But then the second part of a risk register is we also need to then determine how likely it is that a risk is going to happen. If there's a 1 in 10 billion chance that an earthquake, that a meteor is going to land in the middle of the desert, exactly where your particular project is going to happen, then of course it's a risk, but is it really kind of worth putting into the risk register? So what we also need to do, we also need to determine how likely it is that a particular risk is going to occur within a given time period. And so here we've just got a little range of percentages. So an earthquake, there's a 10% chance, 35% chance of bad weather delays, and so on. And so typically what companies do in the deterministic sense is they'll just normally multiply the impact by the frequency or the likelihood, and to get this idea of this average risk here. So this is what we've just got built up here. We have the severity, the likelihood, they get multiplied together, and to give us this risk amount. And then typically companies would then sum this up and incorporate that into their planning. But there's much like the cost estimate model, there's really a couple of issues with this particular approach. The first is that it doesn't really allow you to capture the conditional nature of risk modelling or risks occurring. So when I talk about the conditional nature of risks occurring, if you look at let's take earthquake for example. So if an earthquake happens, then actually it's going to cost us 5 million. That's how much we've worked out. The cost of an earthquake is going to be 5 million if it happens, but there's only a 10% chance that it's going to happen. And so in 90% of cases, actually the amount which it's going to cost us is not going to be 500 or 5,000. It's going to be, or 5 million rather. It's going to be 0, because in 90% of cases this risk is not happening. But in 10% of cases, of course, this value here should really be shown as 5,000 or 5 million, because the risk has occurred. And so if if, for example, we were, so there's a 1 in 10 chance that there's going to be an earthquake. And so 9 times out of 10, if we have 500 set aside in the budget, so 500,000 set aside in the budget, then actually at the end of the project we're going to have a surplus left in our fund. But in that 10% of cases, or that 1 in 10 chance that the earthquake does happen, actually, if all we've allocated is 500,000, but actually the impact is 5 million, then all of a sudden we've got something of a bit of a shortfall and a little bit of a problem. And so the first problem, as I said, with a risk register or deterministic risk register is that it doesn't allow us to capture this conditional nature of risk modelling. The second problem is that, of course, much like the cost elements up here, chances are the actual amount it's going to be is a little bit more uncertain than, an earthquake. It might be 5 million. Well, yes, it might be 5 million. If the earthquake measures number 2 on the Richter scale, possibly it's going to be a lot lower. The buildings might shake, it might scare a few people, but actually it's not going to have any cost impact. If, on the other hand, it's a major quake measuring 10 on the Richter scale, everything gets flattened, actually the cost could be a lot higher than that. So a deterministic risk register doesn't really allow us to capture this uncertainty. And of course, it doesn't really tell us, which risks are the worst case scenario and so on. So what I'm going to do, I'm going to take this deterministic risk register here, and much like I did for the cost estimate model up here, I'm now going to convert this into a probabilistic model. And so the first thing that I'm going to do is I'm going to take these single point values here for the impact, and I'm going to change these into probability distributions. So let's just put some in here. I'll just put some in. So let's use a uniform distribution first of all. Let me just change it here. I don't want to see these static values on there. So I'm going to say that for my first distribution for earthquake, I'm going to have a minimum of 1,000, and a maximum, so a minimum of 3,000 and a maximum of 10,000. For bad weather delays, I will also use a uniform distribution, and I'll say that there's a minimum of 200, a maximum of 3,000. For worker strike, I will use a different type of distribution. So it's worth noting that you can mix and match your distributions. You don't have to use the same distribution for absolutely everything. I'll use a log normal distribution here, where there's I don't actually need shift or static, so I will say that I want there to be a mean of 2,000 and a standard deviation of 400. So a log normal distribution is a different type of distribution where we have this this boundary at 0, and then obviously we have this tail out here, and it's something which is often used for describing risk events, but also for things like reserves estimates as well in oil and gas terms. So I'll just use a log normal there, and also for terrorist attack as well. So this is also a log normal distribution with with a mean of 3 million and then a standard deviation of 800. Okay. So now I have these values which are changing, and so now I'm somehow managing to capture the range of severity which could happen if these risk events occur. And what I'm now going to do, I'm now going to take these fixed percentages here, and I'm still going to use these, but I'm going to use these to really define or parameterize an alternative type of distribution. Now, when I was looking at the cost models here, and also the severities, what I was using was something we call a continuous distribution. So a continuous distribution, let me just load up the palette up here. A continuous distribution is one where we have like a range of values between x and y, sometimes with a little bit of bias, but really any value can happen in between x and y. And so the continuous ones are all grouped together on here. They're all blue. But I'm actually going to use a different type of distribution to simulate whether or not a risk is occurring. So I've already simulated the severity. What I'm now going to do is I'm now going to simulate the frequency. I'm going to simulate the likelihood that a risk is going to happen. And I'm going to use something we call a binomial distribution. And a binomial distribution is something which everyone is going to be familiar with, even if they don't know it. A binomial distribution is one where there are two outcomes. So in the case of my risk register here, the two outcomes are: does the risk occur? Yes or no. If you reach into your pocket and you pull out a coin and you flip it in the air and you put it on your hand and you call heads or tails, that's also another example of a binomial distribution, because it's an event where there are two outcomes. And so whereas for my risk register, does the risk happen? Yes or no. For my flipping a coin, it's do I get heads or do I get tails? And actually, if you were to model a flipping a coin, it would look something like this, because there is a 50% chance that you're going to get heads and a 50% chance that you're going to get tails. Now, in the case of my risk register, oops, let me just cancel that out. I'm just going to build it into here. So if I just put insert function, discrete risk binomial. So you can there's without risk, there's many ways to skin a cat. There's lots and lots of different ways of doing the same thing typically. So whereas before I was just going to define distributions to pick my distribution, you can also right click and you have a number of different at-risk functions grouped together here and sort of the more common functions, or you can go to this insert function, which is where all the different at-risk functions are all together. And so I'm just going to say that I want there to be a binomial distribution in here, and so n is the number of trials, and so n is 1 in this case, and the probability is I'm gonna use as the likelihood here. And so now what I've got in here, I've now got a binomial distribution, and so in this binomial distribution, what I'm doing is simulating whether or not the earthquake is going to happen or not. And so what I've got is this 90% probability that the earthquake isn't going to happen, and so there's a 0 there because the earthquake has not happened. It's a 0. It doesn't happen. But there's a 10% chance that the earthquake is going to occur once, which is what we then have down here. So you can hopefully see that all I've done is I've just built a distribution which has been built up on this parameter here, and so all that's going to happen, if I'm clicking F9, whereas the other values are continuously changing, you can sometimes see that well, most of the time there's zeros occurring in this particular cell here, but sometimes there are ones occurring. And so when there's a 1 which occurs, all that's happened is at-risk has simulated that the earthquake has happened in that particular iteration. And actually what we've got here, we've just got a little function which is basically it's hidden in the background, which is saying that if there's a value in this cell, there's a yes. If there's no value, then actually let's just change the colours so you can see them as well. There we go. So sometimes we've got yes, sometimes we've got no's, and so we've just got a little if statement really just to help us see if the risk is occurring or not. So we've got we've now got a binomial distribution in each of these cells here. So it's been built up on this cell parameter. So just so you can see what I was doing there. So with this particular one, for the earthquake, there was a 10% chance of it happening, this point down here, and a 90% chance it wasn't going to happen. So that's what the height of this bar is really telling us. So if I just change this to 30% and go back in and look at it again, you can see that now the height of the bar has changed, and so there's actually now a 30% chance that the earthquake's going to happen, and a 70% chance it's not going to happen. So what we've got, we've now got a simulated value here, and so now instead of multiplying the severity by this fixed likelihood, what I'm going to do, I'm actually going to just change this by 1 column, and I'm going to say that I want this particular cell here to be equivalent to the contents of this cell multiplied by the contents of this cell. And the reason I'm doing this, let me just hit F9 a few times. Okay, so the reason I'm doing this is because I want there to be this link, or I want to capture this conditional nature of the risk, the risk register or the risk modeling. And so what's going on here is because all I'm doing in this cell is multiplying this by this. When the event doesn't happen, there is a 0 that is placed in this cell. And so if I multiply 0 by this, I get 0 here. If, on the other hand, la la la, 1 in 10 chance, but that's an average. Okay, so there we go. So now when there's a 1 that occurs there, it gets multiplied by that, and it gets included into here. So this now enables us to really capture this conditional nature of risk modeling. It only gets counted if the earthquake happens. If the earthquake doesn't happen, we don't have any amounts in there. And so what I'm going to do, I'm just going to add an at-risk function in here, which is something called a risk make input. And so all the risk make input does, it just really tells at-risk to treat these two as one particular function. And I'm just going to add in a risk name function up here, which is just really going to allow me to know that the name of this cell is earthquake here. So I'm now going to just drag those down. Okay, so what we now have in this column here, we now have, well, in these cells here rather, we now have some risks which, if they happen, they generate a number. If they don't happen, there's no value at all. And so we just add these up down here. And so now what we can do when we run a simulation, turn off demonstration mode. In this particular cell down here, what I'm doing is I'm now capturing the impact of those risks occurring, and so now I can start to model these into my cost model as well. And so here what we've got, so now we have a model where we have the costs here, we have the risks here, and so this little bit down here, if we look at the results, this is now the total budget for our project, which incorporates both the costs and the risk register as well. And so now, if we want to find out what our, let's say our P90 is, our P90 is 24.21 million, whereas if we, whereabouts were we? So that's the total project cost estimate. Okay, so I've just overlaid one on top of the other here. So the red one was the budget before we included any risks, and the blue one is the one where the risks are now included. And so once again, you can kind of see that there's this with the risks. Now we have this long old tail out here, where we now have a very different view on the budget for this particular project. And so rather than just having to being able to or needing to add just an average value, what we've just done, or what I've just asked that risk to do, built up, was the ability to really capture these risks in a very different way, and then to incorporate them into this model. So sometimes they happen. If the risk doesn't happen, it doesn't get included. So it's a much more robust way of building up a risk model or risk register than just taking the average. And so, of course, once we've done this, if I just unhide the final bits up here, we can now start to determine how confident we are in our particular estimate. So rather than just going into here and looking at the results and saying, okay, what's my P90 value or P95 value? Actually, what we can do is we can actually use some of the built-in statistics functions in at-risk to tell us what our confidence level is, or generate really some information about the simulation once we've run it. And so I've just up here, I'm just using at-risk to tell me what my P75, my P90, and my P95 is. And so I've split it down into two levels. So this was the pre-risk project cost. So this was just this value here, and I'm using a function called the risk percentile, which is just really return the percentile value into the spreadsheet from the simulation which I've run here for the project cost, the risk, and then here we have this total budget here. And so now, rather than starting off and going to needing to go to the shareholders or the management or to submit a project bid, which is saying this project is going to cost 18.5 million. Now what we can do is we can start to talk in real quantitative uncertainty, probabilistic Monte Carlo terms, and we can now start to make comments like there's a 95%, or we're 95% confident that our costs are going to be less than 27 million, we're 90% confident they're going to be less than 24 million, we're 75% confident they're going to be less than 21.8 million. And then, of course, we can start to have a much better discussion about whether or not to proceed with a particular project or to submit a particular bid, than just sticking fingers in the air, seeing which way the wind's blowing and saying that this particular project is going to cost 18.5 million. In the back here, I just used some of there's lots of these risk results graphs, so I just used that risk to automatically generate some graphs and put them back into the spreadsheet at the back here. So I think that pretty much covers everything that I wanted to talk about in terms of this particular application of at-risk, so cost estimation and risk registers. Obviously, there's lots more that we can do with at-risk, different types of functions. You know, we have the ability up here to import Microsoft project schedules into at-risk, and also to bring the costs across as well, and to run some models. We have the ability to run time series forecasts. We can do optimization. We can fit historic data to distributions and so on. But I really wanted to spend the time today just concentrating on what I believe are the key functions and benefits of using at-risk for a cost estimate or risk register model. If you go to our website, much as you know, when you signed up for this particular event, it was for whereabouts are we? Let me just go here. It was for cost estimate risk register. Actually, we have this whole schedule of webcasts which are available on our website. So this was the one I was given today, but we also have like more general overviews. This was an overview of the software in Spanish, in French. One of my colleagues is given an overview of at-risk and the decision tool suite, which will show some other applications. There's one on here which is talking about load and resistance factor design approach for civil engineering. I'll be honest with you, I don't know what on earth that means, but someone's talking about how you'd use at-risk for that particular application, so on. So there's lots and lots of these different webcasts which we give, and we also have a very large archive of previous webcasts which have been given. So here there's an overview which I gave in July of all the different tools in the suite, and we have lots of customers on here, everyone from NASA talking about how they use at-risk for their mega projects and cost scheduling, through to lawyers talking about how they use the software for litigation simulation and so on. Yeah, as I said, please don't think that what I've shown you today is all that at-risk can do, but for me, I just wanted to pick out the things that I thought were most relevant from a cost and risk register perspective. So, going forward, does anybody have any questions? Now, obviously, please don't say them out loud because you'll just be talking to yourself. You need to use the chat or the Q&A panel. If anyone's got any questions, please just send me a note and I'll stay on and answer them. If anybody would like to receive a copy of this presentation, so as I said at the start, I recorded the whole session. If you would like me to send it across to you so you can watch it again or share it with colleagues or whatever, then you can just send me an email, and I shall just. So I've just sent everyone my email address via the chat panel. So it is doldfield at palisade.com. That's me. So my name is Doug Oldfield. doldfield@palisade.com is my email address. So send me an email if you want to receive the presentation. Also, if you'd like me to send across this example model that I've been using, I'll send across the model once it's been built up, so you can take a look at it and you know, maybe use it to build up some of your own models. Just if you've already downloaded a copy of at-risk, under help and example spreadsheets, here we have lots and lots of different example spreadsheets to help you get started with the software and a number of different applications. So I think there is a cost model in here as well, but if you want to receive the one that I just sent you, I'll be very happy to do that. Okay, so some questions. So someone has said, can you say something about the percentage contingencies, please? Yes, I can. So what these cells here are showing me, so I've used a particular function from at-risk called the risk percentile function. And so what this percentile function is doing, if we just look at, let's look at this first one here. What this is, so the risk percentile function, it's referring to cell G12
which is this one here, and cell J4, which is this one here. So all this is doing, when I ran the simulation and at-risk captures all this data and it puts it back into this graph here, all this function is doing, it's really just asking at-risk to put this to give us this information in Excel. And so it's saying that the in this particular cell, so in cell J6, there is now a function which is telling us what the P, so this is 75% or P75, what is the P75 for this particular simulation. In this cell, it's telling us what is the P90 or 90% confidence level, also for this one. So you can see that this value here is higher than this one here, and the reason it's higher is because our level of confidence needs to be stronger. And so if we're 90% confident, we're more confident than if we were 75% confident. And so if we want to be more confident that we have sufficient budget set aside, then actually this value is going to be higher, and P95 is going to be higher still. So that's really all the software is doing, and so here we've also got the same function, so the same risk percentile, but rather than looking at the cost value here, instead what we're doing is we're looking at this risk amount down here. So when we ran the simulation, when we look at the results for this particular for the risks down here, what this is now looking at is our P75, P90, and P95 for the risk amount. And then this percentage down here is just what percentage of the contingency do we need to set aside for the risk. And so this is all we're doing here. This risk budget is we're just looking at this total budget down here, which incorporates both the cost and the risk, and we're saying how much we need to set aside in this particular project program or budget for 75% confidence, 90% confidence, and 95% confidence. Okay, so someone else is asking about the link between project and at-risk. So obviously, we talked about the link between project and at-risk, but if we let me just, while there's still some people on here, if by the way, if that's it, if you need to log off now, thank you very, very much for coming along. I hope that you found the presentation useful and interesting. As I said, do send me an email if you want a copy of the model or the presentation itself. For anybody who uses Microsoft Project, you might want to hang around for a little while. Now, in the past, at-risk we've always had two versions of at-risk. So one of them was at-risk for Excel, which is exactly what you've just been seeing. But we also had a version which was for Microsoft Project. And so the version for Microsoft Project enabled us to put in distributions for things like the duration of tasks and costs, etc., and to run a simulation in a similar way. But the issue with that really is that although Microsoft Project is a great tool for planning and project management, when it comes to really modelling any kind of risk analysis, it's really not anywhere near as flexible, because it's really just a glorified database, whereas Excel is a specific spreadsheet tool. And so what we did with the last release of the software, which came out a month or two ago, At-Risk 6, was actually to combine the two different versions of At-Risk into one. And so now, instead of having at-risk for Excel and at-risk for Project, now we've just got at-risk, and the Project functionality is now incorporated into the at-risk for Excel. And so what this now allows us to do is to import MPP files. And so rather than sort of doing it from scratch, what I'll do is just load up on the example model. So if I just load up the risk register and advanced modeling. So what at-risk 6 allows us to do is to really to go into Microsoft Project and to take an MPP file. So if you're not familiar with Microsoft Project, this is what it looks like. This is something called a Gantt chart. here we have a number of different tasks. The tasks have all got an uncertain duration, with start, finish date, and so on. And so this is showing us what our schedule is. So this particular project, this is the start date, the finish date, and so on. And so in the past, we used to have to put in distributions around directly into project, but there was a lot of limitations on doing that. And so what At-Risk 6 allows us to do, it's quite clever, is to take this project schedule and to import it into Excel. And so this is exactly that same project schedule, which has now been taken from project, but is now in Excel. And so here we still have the Gantt chart, but instead of being in project, this is now all copied into Excel. And so the benefits of doing this is that it's a lot more flexible to model any kind of like risk in Excel than it is in project, really. And so what we've got here, instead of having fixed values for our project durations, instead now we've got some distributions about the uncertainty. So now we can have a range of values as to how many days a particular task is going to take, or how much a particular input is going to cost. And what the software is doing, there's now this dynamic link between Microsoft Excel and project. And so what At-Risk is doing, it's just allowing or it's just going into Microsoft Project and asking Project to recalculate the schedule each time we hit F9 or run a new iteration. And so what that then kind of allows us to do is then to find now, instead of having a fixed finish date for a project, instead now we get a probabilistic one. So whereas with the cost estimate model I showed you, we were looking at the actual costs. Now what I'm just doing is I'm using At-Risk to give me some schedule risk analysis. So now this is actually looking at when a particular project is going to finish. And so instead of finishing on the 2nd of February, instead, if we look at the results, now we have a distribution of values for our finish dates. And so what the software is doing, to kind of answer in a very roundabout fashion the question which I was asked by one of the participants, who said, is the MPP to risk data bidirectional? It really depends how you set it up, Angus. So you can set it up so that what you're seeing here has no link to project other than the information that you pull in the first place. And so you could have a separate project schedule with a risk set schedule which is being built up separately, where if you change your risk schedule, or if you change the amounts in the Excel sheet, it doesn't have any impact whatsoever in your project schedule. If, on the other hand, you go to the project settings, you can actually set up how it's linked together, and so you can set it up so that if you want to, you can synchronize from project into Excel, and then back the other way. And I think when you do that, you can. My understanding is that you can. Whereabouts are we? You can change the you can choose how it's synced back. So I think I need to double check exactly how the syncing works, and to tell you whether it picks up the static view or the average, or how it then captures that. But so yeah, I'll double check that and I'll send you an email. But that's kind of exactly what the software is doing. So it's really enabling you to take a project schedule, put it into Excel, and then instead of having these fixed dates, instead to have probability distributions. And of course, then we can put in some uncertainties around maybe some of our resources. We can build in correlations. So much like when I built in the cost model, we can now correlate the amount of time that tasks take, which is obviously or the cost of tasks, which is really useful. We can build in risk registers, so we can now model what the impact of particular risks happening is. variances, and whether they add time to our schedule or add costs. And we can even then pull out things like timescale data report to tell us what the cost of our project is over a particular over the life cycle of the whole project. So we can now go and say, okay, so in September 2013, for our operating costs, we need to make sure that we've got at least X amount set aside in our P80 case and so on. So it's a really useful tool, and it gives you much more flexibility than modeling directly in project, because now we can incorporate all of the standard Excel modeling, etc. So that was just a kind of a little unplanned diversion about projects. Okay, so someone else has said, can you comment on modelling relationships between particular risks and particular cost items? For example, if there was an earthquake, the cost of raw materials may rise. So you sort of using correlations, but we've also been cautioned over doing this by an at-risk expert. Okay. So there's a couple of ways in which you could do this. Of course, you could use correlations. I could see there's maybe a couple of reasons why you might not want to, but you could use correlations to build in a relationship. Let me just close this down and load back up my risk model. Oh, I love Excel 2010. Let me just close this down. So I'm having lots of fun and games with Excel 2010. I'm getting some weird error messages that are coming up, which we can't seem to fix, which is a little bit of an irritation when you're doing lots of demonstrations. Let me just load that back up. So you could build correlations, but you could also build if statements as well. So if it depends on what the type of relationship is between the cost element and the earthquake in that case. So if it was a linear relationship, then you could just use an if statement. So if the cost of the raw materials would rise as a function of the earthquake, then you could just put an if statement. So let's just load up the model here again. I'll just unhide everything. So I'm just waiting for at-risk to load up again. I'll have a little gulp of water while I'm waiting for that, because it seems a good opportunity to, as my voice is starting to get a little bit croaky. Okay, sorry about that. A little gremlin in my Microsoft Office machine. So let me just unhide these to get the risk register back in here as well. So what you could do, you could instead of this instead of the buildings just being based on this value here, you could actually build in a little if statement, which would maybe say something along the lines of, if the value of the earthquake happening is 1, then you would use a different type of distribution for the cost of your buildings or raw materials here. If the value in this particular cell is 0, then you would use a different type of distribution. So you can actually set up just a little if statement, as I said at the beginning, because it's all Excel based. However, all the standard Excel functions work, and so if statements are a really good way of doing conditional modeling in at-risk, if it's a linear relationship. Now, of course, if it's not a linear relationship, then correlations is maybe more appropriate than than not. But you need to be very careful with correlation because, of course, correlation is very much a two-way thing. And so you could be in a situation where your cost of your raw materials is lower than expected, just because there's bad weather delays or an earthquake. So probably I'd be inclined to go for an if statement and just to have two different forms of the same distribution. One if an earthquake happens, one if an earthquake doesn't happen. That would be my suggestion. Someone said, don't worry about the Office 2010 instability. Thank you very much. Now, someone else is asking if there's any possibility to link Primavera to at-risk in future. Unfortunately, the at-risk doesn't link directly to Primavera. There's a little bit of the code which we weren't given access to, and so it's not linked directly. We have actually done some custom development where actually we've customized it so we've kind of automated the process for customers and actually enabled the customer to do that. But there is a workaround, which is that for any Primavera schedule, etc., you've got the option to export that to Microsoft Project, and of course once it's in Project then you could use at-risk 6, which is a little bit more cumbersome, but it is a workaround which some people can use. So I think that's it on the question front. I'm gonna wrap up quick, just in case there's any more. But if there's anything that I haven't covered, or if there wasn't anything that you were sure about, then just ping me an email. As I said, I'll just send it around one more time. doldfield@palisade.com. Send me an email, and I'll do my best to answer your questions or send you the presentation or example models, etc. So thank you all very much for your time. I hope that you found that useful, and hopefully we'll speak soon. Thank you very much for the compliment, Angus. All right, cheers everybody. Bye bye.